Oh, yeah.
All right, you just had a chance to check these ones? Questions on 1 through 6?
Actually, wait, that makes sense. Never mind.
All right, what's YR called? It's a segment, but it's got a special name in this context. A median, right? It connects the midpoint to a vertex. XV, median. T something, median. What do we call the point where the medians meet? Centroid, right? It cuts the medians into 1/3, 2/3 parts. Don't say it cuts it in half, right? It cuts it into a 1/3, 2/3 part. All right, and it's also the point where the triangle would balance. Very good. Questions on 1 through 6? Check these ones. Questions on those? Would you like to see any of them worked out? No? All right. Was the last one 21 through 24? Did I give you all 21 through 24? Yes.
I think so.
I know we need to do 24. All right, any questions on other ones other than 24? All right, let's use our problem-solving skills to figure this one out. Here we go, ready? We're looking for G, J. Let's piece this together. This part of the median is 8, you all agree? What's this part of the median? 4, right? So Nick said, if this is 2/3 of the whole thing, wouldn't 1/3 of the whole thing be half of that? Half of 8, right? You guys agree with that? So what's the whole median's length? 12. What's this segment's length? 5. If this is a right angle, then the angle next to it is also a right angle, right? Linear right there. So this is an interesting picture here. We redraw this. Do you see the right triangle form? And aren't we looking for G, J? This is 5, this is 8 plus 4, it's 12. How do we find the missing side in a right triangle if we know the other two sides? Cool, on top of it. 5 squared plus 12 squared equals x squared. We're going to be using this in a couple sections again. We've already done it this year. We're going to be doing it again, all right? What's 25 plus 144?
179.
169, very good. Square root both sides. 13, very good. So G, J is 13.
Wow.
What's MJ? Who's M? No. What's MJ? Good, because of the midpoint. M's a midpoint. That's 6.5. You understand that? Okay. So just be able to work your way around those pictures. Any other questions on the homework? All right, today's called the triangle midsegment theorem, 5-4. We'll do 5-4 today. We have a quiz review coming up tomorrow. Quiz Thursday. 5-1, 5-3, 5-4. Triangle mid-segment theorem. There's some of the triangle mid-segment theorem details listed out in your chapter 5 theorem sheets. We'll do examples in class today. All right, first thing you need to write down is the mid-segment of a triangle. A mid-segment of a triangle is a segment that joins the midpoints of two sides of the triangle. Very simply put, if you have x, isn't x the midpoint of that triangle on side QP? Isn't y the midsegment of side, or midpoint of side QR? If you join those together, you get what's called a mid-segment. Can you see the difference between a mid-segment and a median? If I wanted to draw a median, I would go from point X. Where would I have to connect that if I wanted to draw a median?
R.
To R, right? This is not that. This connects the midpoints of the sides of the triangle. So X is the midpoint of this side. Isn't Z the midpoint of the bottom side? So that is also a mid-segment. And our last mid-segment connects Y to Z. There are 3 mid-segments in a triangle. When you connect the mid-segments, you get what's called the mid-segment triangle. All right, everybody have that copied down? So kind of interesting, there's a website called geogebra.org. And so I just quickly constructed this triangle, and then I put D, E, and F are the midpoints. And so an interesting thing here is if I connect the midpoints, I'm not sure if that's going to stick there or not. Nope. Easier if I just did it again. Oh my gosh. All right, segment from D to E. Easy. F, F to D. There we go. Interesting properties happen here. Let's see if we can measure. Yep, measure distance or length. So I'm going to measure the length of AC. Right now it's 12.1. What do you notice between the length of AC and EF? Now they're going to have some rounding error, but as I move this, what do you notice? The mid segment is half. Do you see it? Okay, the mid segment, no matter how I move this, is half. Kind of neat, huh? So the first thing we were gonna notice in the mid segment triangle is DE is half of AC. So if DE is 5, what's AE? Or sorry, AC. 10. DE is half of AC. The next thing is they are parallel. So this is in your chapter 5 theorem sheet, okay? They're also parallel. A lot of interesting relationships occur when these are parallel. Always up here for 1 second. Do you see these angles? Wouldn't those be same side interior if the lines are parallel? Wouldn't this one and this one be corresponding? Can you see it? Be honest, can you see the corresponding angles there? Parallel line. Transversal. Corresponding angles, right? So when you have parallel lines, you're going to have corresponding angles. Sometimes you're going to have alternate interior angles, okay, and so forth. So let's go ahead and do this example together. Go ahead and copy down the picture. I'll give you a second to copy it down, and we'll work this one out together. There's a lot of relationships to notice in this diagram. All right, as you finish up, what's BD called again? BD is called a mid-segment, okay? Now, every mid-segment gets paired with a side of the triangle. What side of the triangle does BD get paired with? AE, do you see it? What's their relationship? BD is length compared to AE. Talk about length. Okay, let's go back. Here, DE is half of AC. Here, BD is half of AE. Well, what's half of 17? BD is half of 17. What's half of 17? 8.5, good. 8.5. Now I'm going to ask you some questions that aren't necessarily up here being asked, okay? What's FE? FE. 8.5. How do you know?
It's making 17.
The whole thing's 17, and F is called a midpoint, right? Isn't it cutting 17.5 also? Oh, so kind of a neat little parallelograms formed here. Do you see it? Where these sides are both 8.5. Okay, but the whole thing was 17. All right, let's keep going. What's the other relationship? BD is also parallel to AE, isn't it? So if this angle's 26, what would this angle be? 26, because they are alternate interior angles. Do you see it formed? You see it? Okay. Let's switch our eyes to a different mid-segment. I need you guys to focus here. Okay. Let's switch our eyes to this mid-segment. It goes with this side of the triangle. Can you see it? What's their relationship? FD is half of AC, and they are also parallel. If this angle is 26, what's this angle right here? 26. Isn't this the transversal? And aren't these alternate interior angles? So that's the one they asked us for. They asked us for CBD, 26 degrees. CBD, alternate interior to the 26-degree angle up there. What's angle A? It's 26. These angles are corresponding. Very good. You can see all the different relationships formed here, right? All right. Questions on that? I want you guys to try this one on your own.
Oh, no, I'm just thinking of one.
All right, let's go over this. Logan, what'd you get for JL?
72.
That's what I got. Double that mid-segment, right? By the way, how can we tell this is PN is a mid-segment? It connects a mid-segment connects what?
What?
How can you tell PN is a mid-segment? It connects what's P? P is a midpoint of that side of the triangle. N is a midpoint, it connects the midpoints of the big triangle, right? So as soon as you see that, you know, like Logan did, that JL is double its midsegment, double 36 is 72. PM, is PM a midsegment or a side? PM, midsegment. So it's not gonna be double, it's gonna be half of the side it goes with, right? What's half of 97?
40.
Very good. Last one, L, M, P, this angle right here. Grace, this angle compares, how does this angle compare to this angle? Very good. What's the supplement of 102?
78.
So 180 minus 102, 78 degrees. I didn't ask this, but what would angle L be? Aren't these parallel? Corresponding, right? 102? What's this angle right here? 102, because these are parallel, right? Okay, see it? What would this angle be?
102.
Yep, alternate interior to this one, or, where was I? Alternate interior to that one, right?
Yep.
Very good. Last problem for today. What's this called? Is it a median or a mid-segment? Mid-segment. Connects the midpoints of the triangles. If you ever set the mid-segment equal to the sideline, you may get made fun of. I'm just kidding, I won't make fun of you. However, do you guys see this? Just look at them. Can those two ever be the same length? This guy, no, this guy and this guy, can they ever be the same length?
Nope.
No. So don't ever set them equal. Alright, so there are two ways to solve for n. Tell me their relationship, first of all. Jake, do you have any ideas on this one, or no?
No.
What's this? What is n plus 8? How does that compare to 6n? What's the relationship in a mid-segment? You remember?
N plus 8 has to be half of the 6n.
You got it. So here's 6n. Does it take 1n plus 8 to equal 6n? No, that's what I told you not to do, right? How many n plus 8s does it take to make 6n? It takes two of them, doesn't it? An n plus 8 plus another n plus 8 to equal 6n. That's one option. Option 2. N plus 8 equals, well, you remember how if we were to put in a midpoint here, remember how n plus 8 is equal to half of that side? What's half of 6n? 3n. You could set n plus 8 equal to 3n. That's another option. Half of 6n, right? All right, let's solve this one. N and n make 2n. 8 and 8 makes 16. Subtract 2n from both sides. Divide by 4. I get n equals 4. Now when you plug that in, it should make sense. What's 4 plus 8? 12. This one better be double. What's 4 times 6? Does it work out? Yeah. Now if we solve this one over here, we'd subtract n from both sides. We get 8 equals 2n. And divide by 2, n equals 4 that way as well. Both of those are fine with me. What is not fine with me is if you set those equal. Questions? All right, you guys have about 15 minutes to work on the homework.
Oh, no.